Hello everyone, welcome back to my YouTube channel. I am Siri K, studying at Sri Venkateswara College of Engineering. Today I'll be discussing about OSI model in computer network. Introduction to the OSI model. The OSI Open Systems Interconnection model is a conceptual framework used to understand and implement network communication. It divides networking tasks into seven distinct layers, each with specific functions. The OSI model helps standardize interactions between different networking systems and devices. The seven layers of OSI are application, physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. This is to transmit data, this is to receive data. Overview of the seven layers. The OSI model consists of seven layers: physical, data link, network, transport, session, presentation, and application. Each layer serves a unique purpose and interacts with the layers directly above and below it. Understanding these layers helps troubleshoot and design network system effectively. OSI reference model. Physical data link network transport session presentation application. This is the router, this is a switch, this is a hub, network interface, network, transport, and application. This is TCP or a slash ICP conceptual layers. Layer 1, physical layer. The physical layer is responsible for the transmission of raw bit streams over a physical medium. It defines hardware specifications including cables, switches, and modulation techniques. Examples of physical layer technologies includes Ethernet and USB. Physical layer in OSI model. Physical layer is responsible for transmitting and receiving data over transmission media. Data is treated as an unstructured raw data stream, the actual physical connection between the devices on the network. Layer 2, data link layer. The data link layer ensures reliable data transfer between directly connected nodes. It manages error detection, correction, and framing of data packets for transmission. Technologies such as MAC addresses and Ethernet operate at this layer. Data link layer 2, frame header and CRC, data HTTP, transport packet header. This is A, this is B, this is the network interface card that is called as NIC. This is the overview of the layer 2, that is data link layer. Next, layer 3, network layer. The network layer is responsible for routing data packets across multiple networks. It determines the best path for data transmission and handles logical addressing. IP, that is Internet Protocol, is a key protocol at this layer, enabling inter-network communication. Layer 4, transport layer. The transport layer ensures complete data transfer and maintains end-to-end connections. It provides flow control, error recovery, and segmentation of data into manageable units. Common protocols at this layer include TCP, that is Transmission Control Protocol, and UDP, that is User Datagram Protocol. This is the message, these are the four segments: process, ISP router network, server PC, then it is process. Sequence number, port number, and the segment. Layer 5, session layer. The session layer manages sessions between applications, maintaining connections and controlling dialogue. It establishes, maintains, and terminates communication sessions as needed. Examples of protocols functioning at this layer include NetBIOS and RPC, that is remote procedure call. The session layer The session layer, layer 5, manages the connection between two communicating endpoints. This is about the layer 5, that is session layer. Next, layer 6, presentation layer. The presentation layer translates data formats, ensuring compatibility between different systems. It handles data encryption, compression, and conversion between different formats. This layer plays a crucial role in data representation and user interface processes. This is the presentation layer to session layer from application layer. This is the presentation layer. Layer 7, application layer. The application layer is where end user applications interact with the network. It provides network services to applications, including web browsing and email. Common protocols at this layer include HTTP, FTP, and SMPT. Port, protocol, and description. 23. The is Telnet protocol. Terminal emulation. 21. FTP allows file transfers between computers. 69. That is TFTP protocol. That is trivial file transfer protocol. Have to know what you want and where it is to on the server. No directory browsing, no user authentication. 2004-9 NFS allows remote file systems to be mounted as local, that is, network file system. 25 SMPT used to send mail between mail servers, that is, simple mail transfer protocol. 515 LPT used for print sharing of network printers with TCP or IP, line printer DU. 161 SNMP, that is Simple Network Management Protocol. The description is collect and manipulate network information. 53, that is DNS, Domain Name Service. The description is to resolve FQDN to IP addresses. 67, the boot TP, used for diskless workstations to receive boot file and other information via TFTP. DHCP assigns IP addresses to OS from a pool, can send IP address, subnet mask, domain name, default gateway, DNS IP, VNS info, dynamic, that is dynamic host configuration protocol. Conclusion and importance of OSI model. The OSI model is essential for understanding network architecture and communication. It facilitates troubleshooting and the integration of varied network technologies. Knowledge of the OSI model is crucial for network professionals and engineers. These three layers are the data, the transport is segments, network is packets, detailing frames, physical and bits. This is the media layers, these are the host layers. Thank you.